Good afternoon. This is another video on systems of linear equations. In the previous videos on systems of linear equations, we looked where x, y, and z had a unique solution. So there was a value for x, y, and z. In this video, we're going to look at the following. If the last equation has the form 0 is equal to c, not 0 is equal to 0, please be careful. It must be 0 is equal to a constant number, then there are no solutions. The system is inconsistent. Or alternatively, if the last equation is 0 is equal to 0, there are infinitely many solutions and the general solution can be expressed in terms of t. Let's take a look at two examples. The first one that we have here is I've got my three equations, so I can label them as row 1, row 2, and row 3. Then for myself, if I want, I am just going to express them in terms of their coefficients. So it's going to be 1 minus 2, 1 is equal to 4, minus 2, 4, minus 2, 1, and 3, minus 6, 3, and 12. Now, I can just go and label them again. Now, if I want to start, remember I'm going to rewrite my first equation. So I'm going to write here 1 minus 2, 1, and this is equal to 4. For my second row, I want to eliminate my x values. So in order to eliminate my x values, I'm going to say the following. I normally write here on the left hand side. In this case, I don't have space, so I'm just going to write it here on the right hand side. So I'm going to say row 2 plus twice 2 times row 1, because negative 2 plus 2 is going to give me 0, and then I can just go and say the following: 4 plus 2 times whatever is in row 1, so it becomes 4 plus negative 4, which is again 0. In this case here, negative 2 plus twice what is in row 1, and this is again 0, and then I have 1 plus 2 times what is whatever in row 0. In this case, 1 plus 8 is 9. Then for my third row, what I want to do is I want to say row 3 minus 3 times row 1. That's a 1 there. So 3 times 3 times 1 is 0. Negative 6 minus negative 3 times negative 2. So negative 6 plus 6 is again 0. 3 minus 3 is 0, and 12 minus 3 times 4 is also 0. So I notice something here in row 4 and row 5. It's quickly that I want to say, sure, I see that my final row is 0 is equal to 0. So I want to jump to the conclusion that if my final row says 0 is equal to 0, then I should make z is equal to t. That is what we have seen here above. If the last equation is 0 is equal to 0, there are infinitely many solutions, but be careful. I notice in row 4 that 0x, 0y, 0z is equal to 9. And in row 4, here lies the key. I notice that it is 0 is equal to a constant. So it doesn't matter if I plug in z is equal to t, my fourth row tells me the following. If I arrive at 0 is equal to a constant, there are no solutions. So in this case, I cannot say z is equal to 2 and then use backward substitution to find x and y. For this one, there are no solutions because of my fourth row. Let's take a look at another example. So for this example, we see that I have a coefficient in front of all of my x's, but luckily they're all the same. So it's negative 2, 2, and 2, so they will still be relatively easy to eliminate. So I'm going to write my coefficient here. Negative 2, 1, 3 is equal to 5. 2, 1, 1 is equal to 2. 2, 3, 5, and 9. So what I want to do now is I want to go and label my rows, row 1, 2, and 3. So I'm going to repeat my first row. I'm going to write it again. Negative 2, 1, 3 is equal to 5. Then in order for me to eliminate row 2 for my x values, I am going to say, so this was row 1, I am going to say row 2, and in order to eliminate, to make it 0, I'm going to say plus row 1. So 2 minus 2 is 0. 1 plus 2 is 2, 1 plus 3 is 4, and this is equal to 7. So this becomes my fourth row. For my third row, if I want to eliminate the 2 here in front, I can do exactly the same thing. I'm going to say row 3 plus row 1. So 2 minus 2 is 0, 3 plus 1 is 4, 5 plus 3 is 8, and this is equal to 14. And this becomes my fifth row. Now, I want to continue one more step. I want to eliminate my y value. So first I'm going to rewrite my first row. Minus 2, 1, 3 is equal to 5. I'm going to rewrite my fourth row. 0, 2, 4 is equal to 7. Row 1, row 4. Now for this fifth row, if I want to eliminate my y value, I'm going to say the following. It is my fifth row minus 2 times row 4. So 4 minus twice this is going to be 0. 8 minus twice this is also going to be 0. And 14 minus twice this is also going to be 0. So I notice here for this final row, I'm going to make it row 6. 0 is equal to 0. And right here in the beginning, if the last equation is 0 is equal to 0, there are infinitely many solutions. So I have to make z is equal to t. So what I want to do now, so if I go back here to my final row, I'm going to say z is equal to t. So t can be any other variable because there are going to be infinitely many solutions. Now I'm going to go to row 4 here in the top, and I know that 2y plus 4 times z is equal to 7. I'm going to replace z with a t, so 2y plus 4t is equal to 7. Now I want to make y the subject. So 2y is equal to 7 minus 4t, and y is equal to 7 minus 4t over 2. This is the value of y, and I'm going to leave it like this. I expressed y in terms of t. If I want to find x in terms of t, I'm going to go to my first row here. So I have negative 2x plus y plus 3z is equal to 5. And I'm going to replace y with the value that I found for y. I'm going to replace z with t. So negative 2x plus, in this case, 7 minus 4t over 2, that's a 2, plus 3t is equal to 5. And if I want to make x the subject here, I can just multiply throughout with a 2 just to remove the fraction. So it's going to become negative 4x plus 7 minus 4t plus 6t is equal to 10. I'm going to add my t values, and I'm going to take my constant to the other side. So this is going to become negative 4x plus 2t is equal to 3. I can say negative 4x is equal to 3 minus 2t. Therefore x is equal to 2t minus 3 over 4. Just notice that I already changed because of the symbol here. So negative 2 divided by a negative is going to be positive. Positive 3 divided by negative 4 is going to be negative 3. So now I have a value for x in terms of t, y in terms of t, and also z in terms of t.